In this work, we aim to bridge the global context for the image completion task. We opt to go beyond object removal to deal with true semantic image completion. In particular, when foreground objects are fully masked out, the system should align the background pixels to missing holes. In contrast, when foreground objects are partially masked, the system needs to infer appropriate semantic contents based on these partially visible pixels. However, the conventional CNN will gradually propagate visible information to the missing holes, which will be significantly affected by the neighboring pixels, such as the information flow we visualized for the red point using the recent CNN-based method. It cannot generate plausible results for both cases. How to correctly model the disconnected global context is still a challenge. To mitigate this issue, we first propose a transformer-based architecture to directly model the global visible context in every attention layer. Given a masked image, we first resize it to a fixed scale for token representation and then directly predict the original ground truth using the transformer. Finally, a decoder is applied to generate the plausible completed images. While existing methods have applied the transformer for image completion, most works directly downsample images to 32x32 resolution and build a transformer on pixel-level tokens as in IGPT. While this may not impact the classification, it has a large negative effect on generating high-quality images. Other embedding methods, such as VIT and VQ-GAN, build tokens on feature level, but without considering the visible information flow in the image completion task. To capture the global context correctly, we propose a restrictive CNN to ensure each token gets visible information in a local patch, leaving the long-range dependencies to be explicitly modeled by a transformer without cross-contamination from implicit correlation due to larger CNN receptive field. We compare the completion results on various token embedding methods. Here, we use the same transformer backbone for a fair comparison. As we can see, our method achieves higher quality results than the latest transformer-based completion method ICT, even without appearance refinement processing. For the large center masked images, our TFill-coarse model is able to fill in plausible content on various scenarios, such as buildings, natural scenes, animals, and faces. More results are provided in our paper. Although the proposed TFill-coarse model correctly infers superiorly reasonable content by equally utilizing the global visible context in every layer, two limitations remain. First, the realistic completed results may not be fully consistent with the original visible appearances, such as the completed eye. Second, the transformer model is not suitable for high-resolution input due to the fixed-length position embedding. To mitigate this issue, we further propose an attention-aware layer to exploit the global appearance context for missing holes, such that we can get high-quality and high-resolution completed images. Here, we compare our attention model with existing state-of-the-art attention models for image completion. As we can see, our model achieves better results for correct content, as well as better visual appearance. We report the quantitative results on free-form masks with various mask ratios. As can be seen, our model outperforms existing methods on all metrics. We also show examples of traditional object removal and the latest object completion. Our method clearly removes foreground objects when the whole information is masked out, even for the very large masked regions. Our method also generates reasonable objects, conditional on these partially visible tokens. More examples can be found in our paper. Thanks for your attention.